Okay, hello, second year TS2. This is the first tutorial for the first exercise relating to using the Diva plugin to do an annual irradiation analysis of your house. I'm in Rhino 5, which is the 64-bit version. That's what you need to run Diva. I won't talk you through how you download Diva because I've already put that up on the website, but when you have downloaded it, you'll see these 4 buttons appear in your Rhino. More on that in a minute. What I want to quickly go through now is what the model of your house should be. This is my house. I have modeled it in orange. And if I orbit up here, I've modeled really, I suppose, a very basic level of detail because all that's important for the kind of assessments we'll be doing really is the shape of the building. And that shape is increasingly abstracted as we move away from the building we're looking at, which is my house. So in terms of the level of detail which is relevant, really height and massing is all that you need, and for things that have an impact on the amount of energy that you receive from the sky, anything that obstructs. The only thing we don't include is trees, because they are generally left out these type of assessment. Okay, I've divided this model into 4 layers. You should do the same, and those 4 layers are something that will come into play as we go through subsequent exercises, but to tell you what I've done, 3D walls represent the external skin of my house, and into that I've included things like window frames and openings because they will be important. I've included a layer called 3D walls inside that represents the rooms, that the interface of the inner rooms. And then I've put the glass on a separate layer, and that will be important for later exercises. And then finally, all the surroundings are there on a layer. Do keep to that layer protocol because it will make a difference in a while. Okay, that's the level of detail I want you to build. The one thing I would say, which is very important, is that if I look at this in plan, so I'll set view to top. If I set the view to the top, it's very important that you have got your orientation correct. North should be up the page, south should be down. And that's because obviously the when we're talking about environmental issues, particularly with respect to the sun, orientation is crucial. So please make sure that when you build your model, bring in your site plan that you have north up the page. Okay, how do you then do an irradiation of that? So I've set up 3 views. One view is to the front of my house, one view is to the back of my house, and one view is an overhead view to the rear. To do any of those simulations, you do them one by one. You've got to do 3 things. Though on your Diva tab here, the first thing you want to take is location. Unlike me, your Diva license is probably new, so they won't expire, so you won't get that message. You'll go straight to this, which you probably won't get that either. You'll get to this. Okay, so I will separately email you all the EPW file. That's a file that you need to run this program, and you need to save it to that folder, which is local disk Diva weather data. In that file essentially is all the climatic information which is used to do this analysis. So pick the one that's London Gatwick. That's close enough to your house to be meaningful. Once you pick that, Diva will self-generate a number of layers, none of which you need to know about. So forget about that. You don't need to do anything about nodes, but you do need to do something on materials. So if you click on materials and click on assign materials, this is where the layer protocol comes in. The 4 layers I mentioned earlier are all here. For this, just to keep everything simple, we're only looking at the amount of energy that falls on the surface, so the instant solar radiation. So I only want to just if you could make everything this same material, which is a generic outside facade material, the _35 represents its reflectance value. So this is a material of a 35% reflectance. So if I click that, and then you set all your materials, including, by the way, the glass, which I don't want you to make transparent, just make it the same outside facade material. And once you submit that material information, all those materials are assigned to each of those layers and the objects on those layers. Finally, if you click on metrics, you'll have this, and there's loads of things you can do through this. We're only going to look at one, which is under daylight images, the third along, which is radiation map. The parameters that are there, you don't need to change any of them, but I'll explain to you very quickly what they mean. In fact, I think if you click on that, yeah, it tells you, you can read a wiki article about it. I'll summarize it. What we're interested in is an analysis of how much energy from the sun falls on the surface of my building in a year. And a year starts on 0101 and ends on 12/31 at midnight. So it's 8,640 hours, 365 days. None of these parameters are relevant for you. I'd rather you didn't touch them. The only parameter you might want to change is how big is your image. So you might want to change that. Once you've done that, click this button, Run Simulation. Now, the minute I do this, your computer will be completely consumed by the processing power to run this. It's a pretty heavy simulation. It'll take probably the guts of an hour at least, depending on how much you have built. I would strongly encourage, and please do bear this in mind, don't build your entire neighborhood. Just go, maybe 3-4 houses over, and certainly no more than what I've built here. And there's a very good reason for that, which is a function of how Diva works. But please keep your model tight, keep it only to the areas which are relevant to your house. Once you press Run Simulation, things start to look like the 1980s, and that's because this software, well, this is a very recent software, it actually uses an engine which has been around for quite a long time. I'm not sure it's the 80s, but certainly the 90s. And you'll get this, and this basically is Diva working through a program called Radiance, which is what this is. And your computer, like my computer, will start to gasp with all the energy. Now, I'm going to kill that because I don't need to, because I've already done it. And I'm going to show you what you're going to get out. Okay, so this is the image that finally you will get after the simulation is run through. I've asked you for 3 simulations. This is the front of my house, and then I have 2 more. One is from above, high level, showing the entire model that I built, and then one is to the rear. Now, just a question of what you're actually looking at here. You're not looking at, to be very clear, heat. This is not a question of how hot my house is. This is a question of how much energy from the sun falls on my house over the course of 365 days. And energy, as we now know, is measured in watts, kilowatt hours, and that measure of kilowatt hours is described according to a color, which means that here, this section here, which happens to be the window to my bedroom and the window to my kitchen, receives far less energy over a year than this window here, which happens to be the roof to my little snug out the back. So that's very important, because I can now start to understand which windows receive energy, if you want to call it red t-shirts, and which windows do not. It's a function of not only which way they point, but how they are overshadowed by adjacent buildings and what their tilt is from the horizontal to the vertical. Okay, so hopefully you'll succeed in doing that. We'll be using the software again. If you have issues in terms of making this software work on your computer, because it's a Mac rather than a PC, I'm afraid you're going to have to figure this out for yourselves, but hopefully it will work. Thank you.